Okay guys, we teach you a little about how our network work here. It's a quick review. If you don't understand it, don't be disappointed. I don't understand it either, but it's not important to understand it well. You can use it also without knowing what is happening in the deep layer. When we speak about deep learning, we don't really know what is happening, but what we know is that the answer is great. Okay, let's go. For learning rate, and let's change the Activision function and run it again. As you can see, for every Activision function, the model is working perfectly. This line is the line that is going to separate the numbers. Okay, as you can see, for every Activision function, this is going right. Let's change the model to something hard. Okay. Do you think this is gonna fit this model or not? As you can see, the linear Activision function has no chance. Let's change it to sigmoid and then run it. The sigmoid function is also doesn't have any chance. Let's use tangent. As you can see, it don't have any chance either. Let's look for ReLU. Nothing happened. Okay, what is the problem? Some of you may think, what is the problem? If a function can fix, how we can fix it? I say just add it some neurons. Okay, as you can see, by adding one neurons, the loss is going to be lower. By adding another one, as you can see, the loss is getting lower, and it's equally zero. The neurons is very important. How much neurons we have in every program. Sometimes the neurons are the key to solving the problems. Okay, let's for example change the way of the. As you can see, every pang now answered the program. Because of what? Because we changed the neurons. Okay, now you understand why we need neurons. One of the things we need either is hidden layers. Let's see if we have, for example, a lot of these things, but we don't have any hidden layers. Do you see, the hidden layer is the thing that makes the program solve. We need to have hidden layers for solving the program. By adding one hidden layers, the hardest problems solved. Okay, it's going to not solve, I think now. Let's just delete these neurons and make it 2. Okay, let's make it 3 and 4. Okay, the program has been solved. Or we can use sigmoid. Why we need ReLU? Because ReLU is really faster. As you can see, look, ReLU is really fast, but sigmoid and tangent are slower. Okay, let's go for another models in the next lessons. Have a good time.